The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show. Karen, what are we going to be finishing in today's episode?
We've finally reached it. The conclusion of the super glue gun. It's time for the final countdown.
Yes, that's right. In today's episode, we're going to do the final design, 3D printing, and assembly of the parts to create the super glue gun. It's been a long journey, but now that journey is over.
Yes!
Let's get started.
Amazing hacks.
Should we take it for a spin?
Inspired designs.
Imhotep's priests.
Regrettable acting.
No one seems to get it.
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
I did some more design on the gun barrel. I think I know a way to get the wires through. So I have a few pieces here, front and rear wood, that will hold the barrel in place. I'll have to cut some holes in them. I will laser cut those out of wood. Anyway, so what I did was I made a few changes to the motor cap stuff. I put a groove in the bottom of it right here, which isn't very pretty. But I think that will be enough to get the AC and temperature sensor wires out of the barrel. And then in the back of this, I added a few more slits, actually moved them from where they were before. There's a slit here that's coming down out of the cap, and that will be for the motor driver, hopefully, if it works. Yeah, see there's a groove for it there as well. So that groove should match up with this groove. Yeah, see there's an opening right there through the hole there, and then all those wires will kind of come down here, down by where the glue stick enters. See it from end view here. So the motor drive comes down here, hot end stuff comes in here. It's not a lot of room, but I think it's enough to work. So then if we think about the barrel, let's see if we can do a section analysis of it. Let's reduce that down, there we go. So what I did was I created another chamber right below the glue stick. Right there, that chamber right there that I'm indicating with the mouse. And so those wires will come into that, they'll go into that chamber. From the side view, we'll see that that chamber basically is right under the glue stick loading area. Then it comes back here and then it goes straight down there, and that is where it will basically go into the main body of the gun. Yeah, so I've got the Mod Podge, slide stand, catch lever, all this stuff. That's basically what the top of the gun will look like. And then the gun will print in two halves. They'll be like that. And then the handle will be here. And then that's bigger than any of my printers can print. So what I'll probably do is just print the two halves separately, or the four halves, I should say. I'll print the two halves of the barrel, then I'll print the two halves of the handle, then I'll glue them together so they represent what a solid piece would look like. But as is just beyond the size of my printers. Okay, so on the front hot end of the gun, we have the AC barrel heater and then our analog temperature sensor. Now I realize there's a few other things we have to take into account when we put this together. We have to actually have this inside of the barrel because we can't stick it in if the motor is already in place. See, that's gonna go right about there. We've got this groove here where we can run the wires. All right, so we got that, and then it goes into here like this. And then these wires are gonna come down like this, I guess. So now what we have to do, I think I'll just put some Kapton tape around one of these ends. Actually, I don't know which end, probably this end. I guess I could lightly glue it. Look, everything fit. The wires go under this motor can thing, and then we have our AC wires, our sensor wires, and our motor drive wires all coming out this back slit here, which will go into the base of the handle where all the electronic controls are. Cool, so now that I know that works, I'm gonna go ahead and 3D print the other side of this that I mirrored earlier. Then I can 3D print the handle with a few slight changes, glue them all together to make 2 halves, and then we should have a completed prototype. Okay, I reprinted the 2 bottom halves of the gun, although I did make an error. I forgot to fully print the opening for the programming port. I might have to dremel that manually like a cave person. See, I was being politically correct. I didn't say caveman because there are cave women too. And cave, what are those things called, like woolly mammoths? All right, so the same as the rest of the gun, all the screw holes will be on the same side. So just test this out. This will go here. Our wires will go into the gun like that. So here's the spring. I've got a little round nub for it to sit on, and that is the stand release spring. Let's just see if it works. Cool. And more importantly, let's see if it clicks when I go back into position. It does, and look, it's ambidextrous. So if you're a righty or a lefty, you can use this glue gun. Oh, we should sell like custom grips for this. Like there could be like a checker grip, composite, walnut, probably not ivory. It wouldn't go over so well anymore. So what I'm gonna do here is I'm actually gonna glue this in 2 parts. First I'll glue on the bottom handle, then I'll glue on the top handle. So basically it will simulate this being one half and that being the other half. Yeah, I'll probably just do this side first, and then I will transfer over the circuit board from that glue gun. I have kind of the old style trigger where all it had was a magnet and a spring because we've removed the capacitive touch sensor. So I'm gonna glue this up, let it set, and then we'll start putting some parts into it. And actually what we can probably do is just test to see if it works before we fully complete the build. All right, I'm gonna do a test here pretty soon of the motor at least, to see if I wired it correctly. I have a 50% chance of doing it wrong, so it'll probably be wrong. That's how things go around here. Let's test the stand. There we go. Obviously half the handle is missing, but you get the idea. This is like one of those things where they cut open a cow and they show you its guts at like the fair. That's kind of gross. All right, I'm gonna check the motor, make sure it's going in the right direction. Then what I'll probably need to do is change the temperature profile because the original one that we did, which actually is right here, ta-da, was off a different barrel. So we'll probably re-extrude the glue and then see what its temperature is and then scale the thermistor settings to match that. All right, it's plugged in. See if the motor still turns. It's going the wrong way. Well, that's okay. I can just take this header, and then these pins aren't too difficult to swap around. You just have to push on the tab on the back a little bit. There it goes. Of course, the barrel's not on. All right, so what I'm gonna do next is finish gluing the other side of the case, which is this right here. Then I'll mount it in place. See, these 2 posts here will hold the circuit board down, so the circuit board will be nice and stable instead of loose like it is now. Yeah, and then we can do an extrude test. Okay, let's give it a test. So I'm a little concerned that there might not be enough insulation to prevent the case itself from melting. So here it goes. It's powering up. We'll just wait for it to get hot and then we'll try to extrude some glue. I can kind of feel it now. All right, let's do an extrusion test. Full power. Load up another glue stick. Oh, I should like write my name. So glad I learned cursive in grade school so I could write beautiful hand-drawn letters. All right, looks like the glue stick. Okay, here comes the next one. Oh, something popped loose. All right, I'm gonna power it down because I think we're running into that heat problem I worried about. I dug up my old phone that has micro USB so I could plug in the Seek Thermal. Wow, look at all that heat around the gun barrel. 187 degrees Fahrenheit. So that's the surface of the, plastic gun. We're definitely pushing what this plastic can, sustain, or we've probably gone past it. Let's see if this will even go back in. I don't know, this design might not have what it takes.
Hey, Ben.
What?
Stick them up.
Oh, yeah, stick around. Well, we finished the prototype of the hot glue gun. So what we're gonna do is we're gonna compare our dreams to reality, which is something that everyone must do at some point in their life. We wanted an auto-retracting stand.
I love the auto-retracting stand here, which I'm not going to demonstrate because when we heated it up, we don't have the correct plastic.
It got warped.
Warped slightly, doesn't.
Yeah, we tried doing a mechanical one where there would be a touch-sensitive thing on the trigger. So basically, when it detected your skin, it would have a stand that would retract mechanically with a motor. And we had an episode about that where we had the servo in front of the trigger, but it was just really, really bulky.
Yeah.
And it didn't really have enough room to go back in the gun, so we redesigned everything again.
Yeah, so an electrically triggered automatic stand wasn't really feasible.
Yeah, I mean, there's room for the stand, but there's not room for what drives the stand, which is why we did the spring-loaded version.
I think it's a good compromise.
Yeah, I mean, even that though, it wasn't a lot of room for everything.
No, and I'm still concerned about it being sturdy enough. I mean, like when you set it down, it was pretty good, but I think it could be sturdier, and also when this pops out, you have a tendency to want to push it back in with your hand, which gets you right on that hot nozzle.
And the fact that it's got this slope here makes it kind of hard. So I sloped it to make it take up less space, but that also makes it harder to push it back in using a table or something. So that part was not optimal either. Okay, what else do we have? Oh, reasonably sized glue extruding gear and motor.
I think you were able to fit a motor in here with a reasonable size. I don't think the bulk looks gaudy or unreasonable.
Yeah, I mean, that's pretty much the smallest motor that would actually extrude the glue. But the problem we had was any motor small enough to fit was not strong enough to extrude glue sticks larger than the mini size.
Right.
So we tried doing 1/2-inch glue sticks and that didn't really work. We ended up with this, and some people complain that they don't like the mini glue sticks.
Well, I ran a poll on the Element 14 community, and a consistent 80% of people said that they would rather have a smaller gun with fine controlled extrusion rather than like lots of bulk like a caulk gun.
Okay.
So I think we're actually appealing to a larger audience with this design.
Okay, what's next?
Let's
Compact sized. So again, like we just said,
given everything you added in here, and this is something that you made in this shop as opposed to being able to, engineer it down to as small as physically possible with mass production, I think you did a great job keeping it compact.
It's still kind of big though.
It is a little bit.
It's the size of like a normal mid-range glue gun, like an Eileen's or something like that.
Yeah. I don't think it's unreasonable though. I mean, if I saw this in a case at a craft store, I wouldn't think like, oh wow, that's huge. I would be like, oh, it's a super glue gun. Well, obviously it's going to be bigger than a regular glue gun. It must have a bunch of cool features.
It fits the hand well. It's got the thing for your thumb and the programming port. And then I think this probably could have been extended, like, to put in glue sticks. Smart microcontroller driven.
Yeah.
So yeah, it's got a temperature sensor. It's got an ADC, a Hall effect sensor for the analog trigger. It has a bunch of sensors. Actually, we had extra I/O in the end.
Right.
So yeah, that little AT Tiny 20 certainly had enough I/O on it. And yeah, the program wasn't really that difficult. It was kind of fun trying to squeeze all the timers we could out of that chip because there's only like 2 timers. I think we used one for the servo and then the other one was used for the motor. So that was kind of fun doing like really low level timer libraries. Also, finally, cool design. I think it looks pretty cool.
It looks pretty cool.
Yeah.
This looks like a video game gun.
Yeah.
That's pretty cool.
So yeah, I mean, we spent a lot of time prototyping things for this super glue gun. I think the final prototype we came up here is about the best we can do in our shop. So I guess we'll see how people feel about this and, you know, think about if it's worth pursuing. I kind of think it's probably maybe a little bit beyond us, to be honest. But, you know, at least we have a final prototype now.
Yeah, I think it was a good idea. I don't know that it really has enough
it's like
features to really justify the cost of what it would be as a product.
If we could have done all these things really well, I think it would have had a chance. But I mean, as is, like, you know, like, do you remember when we did the touch-sensitive trigger? That was super cool. So we have the electronics for the touch-sensitive trigger, but we don't have room for the mechanics to make the stand work.
Yeah.
So it was like half a dozen of one and 6 of another.
Yeah.
It's kind of tricky. But you know, even if this doesn't go anywhere, we got to play with triacs, we got to play with touch sensors, new microcontrollers, and design a really cool looking glue gun. So, you know, even if this isn't the long-term project that makes it in the end, there were still a lot of cool adventures along the way. That's all we have for today.
So what do you think? Does the super glue gun live up to its name? Does it have what it takes to make it on the consumer market? Tell us your opinions on the Element 14 community on element14.com/TBHS.
You can also go there to read about other upcoming episodes, builds, and special events. We'll see you next time. Dear lefties, we feel bad because the world was not designed for you. Also, you statistically have a shorter lifespan. That's why we designed our super glue gun for your needs. Welcome to Sloth Park. Dee, 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 dee. They're moving slowly. They do move slowly. Now, real warrior, upon testing the ZF1, would have immediately asked about the little red button on the bottom of the gun. Glue gun? You were the chosen one! You were meant to extrude glue, not to clog it! Future Academy Award winner, Gary Oldman. That oven smells great. Can you smell what the rock is cooking? That's right, it's another reboot.
I thought today we could do a teardown of your Sega Saturn.
I think this battery is totally dead. Oh yeah. Wait. Yeah, it's mostly dead. I think the Sega Saturn is like a master course in how not to design a system.